Good afternoon, colleagues. I think we can start now. It's 4 o'clock. Welcome to this afternoon's deep dive session. For you, everybody, welcome. I'm John Kloppers. For those of you who has not met me before, I'm a senior medical scientist at the University of the Free State NHLS, Department of Hematology, and I will be chairing this meeting this afternoon. It gives me great pleasure to introduce Dr. Raquel Viana this afternoon. She will be giving us a talk on the genetic characterization of lymphoid cancers using a newly developed next-generation sequencing panel. Next slide, thanks, Bridget. So just some housekeeping notes for everybody to take into consideration. As per usual, recordings can be found on the www.blood.sa website under Resources, Deep Dive. For any questions and answers, please leave it in the chat box and we can look at them once the talk has concluded. Then the mailing list, please remember to email your request to be added to the mailing list to Melanie. CPD points will be automatically submitted to the HPCSA for each attendee. Please just ensure that attending with your own registered Zoom account and not in a group. If you have any queries regarding CPD, you can contact Melanie. And just note 1 hour attendance is required to qualify for CPD points. Further to that, Blood SA really appreciates your feedback. So there's a survey that you can return. This is anonymous, so please respond so that we can keep these talks of good quality. Then next slide, thanks. Just a reminder of the exciting 16th Annual Hematology Oncology Symposium taking place from 13 to 15 September this year in Cape Town. Hematology in action, getting smarter in hematology, and we look forward to welcoming everybody there. Next then, just a reminder of our management team for you that don't know them at Deep Dive. Team leader, Professor Estelle Verburg, then the National Training Coordinator, Gerdien, CPD Administrator, Melanie, and then our National Coordinator, Bridget. Then, as I said, this week we're going to look at, or we're going to hear a talk from Dr. Raquel Viana on the genetic characterization of lymphoid cancers using a newly developed NGS panel. And then next week, we will have a talk from the UFS on the blood, the brain, and the barrier in Sézary syndrome. So just on our speaker today, as I said, we're quite privileged to have Raquel with us. She's the head of molecular pathology at Lancet Laboratories with years of experience in diagnostic pathology. She completed her PhD at the University of Wits in collaboration with the Center of Vaccinology in Ghent University in Belgium. There, she spent 3 years specifically working on hepatitis B virus as well as hepatocellular carcinoma. She then came back to South Africa, completed her training in molecular medicine at hematology at the University of Witwatersrand. And she currently heads the oncogenetics and specialty molecular division at the molecular pathology department at Lancet. So welcome to you, Raquel, and we're very much looking forward to your talk, and especially on such a topic where we've heard much about myeloid malignancies and the molecular background to those, but lymphoid is something that's also coming to the horizon now. So thank you very much.
Thank you so much, Jean. Great. Just want to check if you can see my slides.
Yes, we can see your slides, Raquel.
Thank you. That's great. Thanks so much. Thank you, everyone, and thank you so much for inviting me to talk on today's hematology deep dive session. And thank you to everyone that's joined in this late afternoon on a chilly day here in Johannesburg. And today I will be talking to you about our experience with a new targeted lymphoma NGS panel. Okay. So I have nothing to disclose. Just going to stop my video because I can see it's got a problem in sharing the presentation. Can everyone see my disclosure slide?
We can see that. Thank you.
Thank you. Thank you. Okay, I will continue. So just a brief outline of what I'm going to be covering today in this session. I'm going to start with a very quick overview of the classifications of lymphomas for those of you, which I'm sure there's very few, that may not be familiar with this malignancy type. I will then be covering what we know so far in regards to the genetics of lymphomas and focusing on the more common B-cell lymphomas, though I will briefly touch on some of the T-cell lymphomas at the end of the session. I'll also detail the new Iron AmpliSeq Liverpool Lymphoid network panel that we validated and recently launched. And I'll discuss the genetic characterization of the validation specimens we processed using this new panel as I go through the genetics of the various lymphoma types at the same time. So it will be a bit of a mix. So as you all know, back in 2022, both the WHO and the ICC published competing classification systems and have indicated that they will retain the separate classification system going forward. So what does that mean for all of us in practice? Well, a recent abstract at ASH last year from the Mayo Clinic team actually looked at comparing these two classification systems for a large cohort of about 5,730 lymphoma cases and showed only a major discrepancy in around 0.8% of cases, indicating that the two systems are actually highly comparable and equivalent, which is great for us in practice. The traditional classification of lymphomas will divide lymphomas into two major types, that being Hodgkin's lymphoma and non-Hodgkin's lymphoma. Hodgkin's lymphoma is extremely rare and characterized by Reed-Sternberg cells. Typically, this lymphoma involves lymph nodes that are swollen in the neck, chest, and under the arms, and typically progresses to involve more lymph nodes in the body, like in the abdomen, and in advanced stage can evolve to other organs, like the spleen or the liver or the bone marrow. Non-Hodgkin's lymphoma is the more common, or at least is more common than Hodgkin's lymphoma, and is subdivided into two groups, with T-cell non-Hodgkin's lymphoma being the very rare, and the B-cell non-Hodgkin's lymphoma being more common. And as you can see, we have more than 90 subtypes that can be found between these groups. So non-Hodgkin's lymphoma subtypes are further characterized according to how the disease progresses, with aggressive lymphomas being fast-moving and accounting for about 60% of all non-Hodgkin's lymphoma cases. Indolent lymphomas are those that are slow-moving and tending to grow more slowly and have fewer signs and symptoms when first diagnosed. The most common indolent lymphomas are follicular lymphoma and marginal zone lymphoma. Mantle cell lymphoma rarely may be indolent, but mostly presents as aggressive. The most common aggressive lymphoma is your diffuse large B-cell lymphoma, with one of its subtypes being the more aggressive, referred to as your double hit DLBCLs, and the most aggressive lymphoma being the high-grade Burkitt's lymphoma. So in order to classify these lymphomas, we have been using for some time now a number of classical techniques. And these include your H&Es, your immunohistochemistry, and your flow. And then in more recent years, we started using some other techniques to assist in supporting or refining the diagnosis of these lymphomas. And these included utilizing clonality assays to identify single or multiple clones arising. We also used PCR and Sanger sequencing to investigate mutations in single genes. And we have also had FISH to study copy number alterations and structural variants. And then some more robust versions of PCR came around with your real-time PCR and more recently digital PCR to investigate single genes and quantify the mutational burden or expression. Other more recent techniques are your gene expression arrays to quantify gene expression of a number of genes to help inform cell of origin, and what we will be discussing today, which is your next generation sequencing to perform multiple gene analysis. So using NGS has shown that lymphoma has genetic alterations that are very heterogeneous. But what starts to be found are these specific mutational patterns that start emerging in the data. So in the last 5 years, there has been an immense amount of data and publications focusing on the genetic landscape of lymphomas, all contributing to a better understanding of the pathways and the genes involved in each of these different lymphoma entities. This is just a recent review that gave a very good summary of all of the different genes involved, and also highlighting that certain extranodal sites are associated with specific mutational signatures as well. So also important to keep in mind when processing these type of samples. So a few years ago, we started receiving requests at Lancet Laboratories for a lymphoma NGS panel. At the time, a publication by a panel of experts had literally just been released, detailing recommendations for such a panel. And basically what they concluded was that the panel needed to be an optimal panel that covered diagnostic. This needed to be both positive and differential, prognostic and theranostic requirements for the different lymphoma subtypes. And all of this needed to be achieved while the panel remained sufficiently simple to allow for uniform application, which in a diagnostic lab environment is basically what we aim for. So keeping all of this in mind, we performed an extensive literature review. We reviewed all of the diagnostic, prognostic, and therapeutic gene targets that were listed in the various guidelines and classifications at the time. And obviously, we first started off with investigating any commercially available kits on the market, but we quickly found that none were comprehensive, and the gene targets had become basically outdated in the panels that we had found. We reached out to a number of suppliers when we were looking for these commercial kits to see if they may be in the process of developing some panels that were imminently being launched. And one of these suppliers at the time, when we reached out, responded to our request and basically informed us that we weren't the only laboratory reaching out to them regarding a lymphoma panel. And they actually suggested whether we wouldn't be interested in potentially forming a network to be able to evaluate or produce such a panel. So in 2022, we joined the Liverpool Lymphoid Network, focusing on validating a comprehensive targeted lymphoid NGS panel. So 11 sites participated in this network. You can see that the bulk of the sites were all within the EU, with 3 sites in the UK, 1 in Ireland, 2 in Germany, 2 in Spain, 1 in Portugal, and 1 in France. And we were the only site outside of the EU and the only site in Africa to be participating. We were also uniquely positioned within this network team in that we had 2 instruments that we would be able to evaluate this panel that we were going to start testing out, whereas the other laboratories had only use of one or the other. This network has since increased with other sites now in the rest of Europe coming on, and in Australia. And they will be continuing to participate in upcoming evaluations and are also involved in implementations of this panel now. So the details of the actual panel. The panel created is a DNA 60 gene panel and does not include any RNA targets. That means that we are not covering as yet any gene expression or rearrangements in this panel. And this was decided upfront right at the beginning when forming this network for two reasons. One being that we wanted to keep the panel as affordable as possible, and the other being that there were already existing techniques such as FISH that were already being utilized. So we wanted to try focus on what wasn't on offer. Also, there were existing RNA panels that could potentially be utilized for these RNA evaluations for rearrangements and gene expression. A new version of this panel may in future, however, include an RNA component. It is something that we had left on the cards if there were enough members interested in that. So that may be something we'll see if we ever update this panel. The panel design was based on information that you see listed there. We included information on the WHO classification of tumors, the 4th edition. Before it was finalized, we then also cross-referenced the 2022 5th edition released in 2022, the ICC classification. We researched a whole bunch of publications on lymphoid malignancies. There was quite a bit of importance also placed on being aligned with the NHS England National Genomic Test Dictionary for lymphoid malignancies for the labs that were taking part from the UK. And we, of course, looked at the incidence rate of the lymphoid malignancies, wanting to obviously cover the more common ones really in depth. And then we had some assistance in terms of the back end, having somewhere to start by using some knowledge that was already present with the Oncomine lymphoma core panel that was available. In blue there, you see that there's a little block with some additional genes that are included. This is part of our spike-in that wasn't part of the evaluation that I'm going to be discussing today, but we have launched with the spike-in genes included. Okay, so phase 1 of our panel validation with the other 10 sites that were involved testing pre-characterized specimens across the 2 platforms, this being the GeneStudio S5 and the Genexus platforms. The pre-characterized samples that were tested included a number of commercial controls, as well as pre-characterized samples from each of the lab's own biobanks. We then utilized this data to come up with a back-end workflow and also did a number of workflow optimizations in terms of the processing on board of the instruments. Phase 2 of the validation then involved evaluating concordance between labs, utilizing clinical lymphoma specimens. 3 phases of the evaluation are now being prepared for publication by the network, and the second phase included 176 data points. And I will not be going into this data. This data is already being prepared for publication. I'll then be describing the next phase of validation that we did, that we performed. Okay, so after phase 2 was completed, we were all confident within the network that we had sufficient information and everything had been set up sufficiently to launch the Iron AmpliSeq Liverpool Lymphoid Network Panel. It was launched to cover a large spectrum of lymphoid disorders that are listed here in the slide, and again included the 60 key DNA genes. The panel was launched to be able to be processed on both of the Thermo Fisher instruments, so it could run on an S5 instrument as well as the Genexus instrument. It was a 2-pool DNA library prep. The amplicons averaged in size at 119 base pairs. This was by design to obviously accommodate FFPE tissue specimens. And the great thing about this panel compared to a lot of the other panels that were available was that you needed as little as 10 nanograms to be able to process and get good quality data. So our validation cohort that we then processed in South Africa was made up of 50 lymphoma and lymphoblastic leukemia specimens, with the lymphoma types detailed in the pie chart that you see there in the slide. And we tried to, in this cohort, include as many different lymphoma subtypes as we could, and also as many different sample types. The most common subtype that was evaluated, which isn't surprising, is your DLBCL. And we had predominantly male patients, again, not surprising considering what we know about lymphomas. So the first step when we started the validation was to extract DNA. Again, like I mentioned, we wanted to include as many different specimen types in this validation cohort to see how the panel performed. So we included FEPE lymph node biopsies, orbital biopsies, trephine biopsies, bone marrow aspirates, as well as a CSF specimen. We did run into some difficulties in regards to sample availability when FNAs were collected, where you had very little tissue. We did attempt some of them, and we did get good data except for one. Okay, we decided to proceed in our lab with utilizing the Genexa system for our validation over the S5 system. The reason for this was that there were advantages in terms of the back-end analysis, and it was also a quicker hands-off workflow. So we were able to basically extract quantified on our qubit system, loaded it on the Genexa system, and within approximately 20 hours had the data. Okay, now looking at what we actually found with our validation, mutations were observed in 45 out of the 60 genes covered by the panel. The incidence of these mutations are similar to those described in the literature, and the number of genes found to be mutated in a relatively small cohort really does speak to the selection of the genes that were included within the panel. And the most commonly mutated gene being KMT2D. Now looking at the number of genes mutated per patient, we observed that the higher number of mutations were observed primarily in DLBCL patients, again aligning with what has been published previously. We'll now delve into some of the lymphoma subtypes, focusing on mature B-cell malignancies, and then cover what was found within these entities for our validation cohort, starting off with follicular lymphoma and what we know genetically within this subtype. Okay, so we know it's the most common indolent B-cell lymphoma. It's derived from germinal center portion of the lymph node. It typically expresses CD20 and CD10. It's graded on a scale of 1 to 3 based on the number of centroblasts, and it typically has a presentation as asymptomatic peripheral lymphadenopathy. It frequently presents as advanced stage disease, and its key hallmark is the T14/18 translocation. So recently there was a study back in 2020 that showed a distinctive diffuse follicular lymphoma variant lacking T14/18. And this was described actually for the first time back in 2009. And in a more recent study using NGS analysis, they actually found 2 molecular clusters that were identified within this entity. One was characterized by the TNF-RSF14 mutations and frequent mutations also in epigenetic regulators. And the other cluster, molecular cluster, showed few genetic alterations. However, a subgroup with STAT6 mutations concurrent with CREB-BP mutations without these mutations in TNF-RSF14 and EZH2 mutations was also noted. These findings suggested diffuse follicular lymphoma might represent a subtype of T14/18 negative follicular lymphoma, which is now a recognized entity. What about genetics in the use of prognosis within follicular lymphoma? The most original prognostic system is called the Follicular Lymphoma International Prognostic Index, otherwise referred to as FLIPI. This system looks at the patient's age, stage, hemoglobin, and the number of nodal sites and serum LDH. There was another iteration of this index called FLIPI-2, and now more recently, the M7 FLIPI score that incorporates the mutational status of 7 genes, the Eastern Cooperative Oncology Group performance status, in addition to the original FLIPI score markers. So the M7 FLIPI system showed more segregation of the low, intermediate, and high-risk patients into more succinct subdivisions and incorporates mutations in the 7 genes listed in red on the slide. What about genetic evolution within follicular lymphoma? What do we know about that? So in 15 to 30% of follicular lymphoma patients are known to transform to a clinically aggressive lymphoma, which is usually associated with a poor prognosis and chemotherapy resistance. This transformation has been found to be associated with mutations in CDK2A or B, MYC, and TP53. In a study comparing patients that transformed, the presence of mutations in 4 genes at diagnosis of the follicular lymphoma were also found to be associated with a shorter time to transformation. So now looking at our follicular lymphoma patients within our validation cohort, we included 4 patients that were diagnosed with follicular lymphoma within our validation cohort and found mutations in KMT2D in all 4 patients. This was not unexpected, as mutations in KMT2D are the most commonly observed in up to 72% of patients with follicular lymphoma. The one molecular subgroup described in the previous slide, where we discussed one of the molecular subgroups co-occurring with CREB-BP and STAT6 mutations in the absence of the TNF, SF14, and EZH2 mutations, were observed in 2 of our patient oncoprofiles, in FL1 and FL3, supporting the diffuse follicular lymphoma subtype. We also observed mutations associated with the M7 FLIPI system in CREB-BP, EP300, and STAT6. Now moving on to the next lymphoma subtype, marginal zone lymphoma, which forms part of the group of indolent B-cell lymphomas. These arise from a marginal zone of the B lymphocytes and is made up of 3 distinct clinical entities with genomic overlap, as seen in the side. So we included 3 patients diagnosed with marginal zone lymphoma within our validation cohort and found mutations in KMT2D in all 3 patients. Mutations in KLF2 that are one of the most commonly observed were not included in the panel. But as mentioned before, this is one of the genes that we are running as a spike in, but we did not include it in this initial validation. We did also observe mutations in genes involved in the activation of the NF-kappa beta pathway in CARD11 and NF-AIP3 in 2 of the patients associated with possible therapeutic targets. Now moving on to chronic and small lymphocytic leukemia. CLL and SLL are both slow-growing subtypes. CLL involves the accumulation of abnormal B cells in the blood and the bone marrow, while SLL involves the accumulation of abnormal B cells mainly in the lymph nodes. Somatic hypermutation of IGHV, otherwise referred to as mutated CLL, is known to confer a better prognosis than the absence of mutation, otherwise referred to as unmutated CLL. SF3B1 mutations are frequent in this entity and only very rarely seen in other lymphomas. And this is something that is rare because, as you know, heterogeneity, quite a bit of overlap within the lymphomas. But SF3B1 mutations we normally only commonly see in CLL or SLL. Several recent NGS studies have identified other genes with prognostic relevance within this entity, and that includes Notch1, SF3B1, ATM, and BERK3. TP53 mutations are observed in 4 to 37% of CLL and SLL cases and are associated with chemorefractoriness and reduced overall survival. In patients with TP53 mutations, it is believed that they will benefit from treatment with a BTK and BCL2 inhibitors, although the poor prognosis does remain. Okay, resistance to covalent BTK inhibitors is seen with acquired mutations in the BTK gene. There is one specific, more common site associated with this resistance at codon C481. There are also acquired mutations associated with resistance in PLCG2 and CARD11. Mutations in BCL2 are associated with venetoclax resistance, and Richter's transformation, which is when CLL transforms into an aggressive lymphoma, usually that being DLBCL. The pattern of mutations are normally different in the de novo DLBCL compared to this Richter's transformed CLL. The risk of transformation is associated with prior therapy, unmutated CLL, Notch1 mutations, and a deletion of 17p and 11p. So looking at our CLL validation cohort, we included 4 patients that were diagnosed with CLL and found different mutations across the 4 patients that we selected. We observed mutations in BERK3, SF3B1, and TP53, all associated with a prognostic impact. In the patient with BERK3, the CLL1 patient, we also observed a BCL2 mutation associated with venetoclax resistance. So it was just lucky that we were able at random to actually get 4 different profiles from the specimens that we had selected, which was great. Now moving on to the more uncommon low-grade B-cell lymphoma, LPL and Waldenstrom's. This lymphoma involves bone marrow infiltration of clonal lymphoplasmacytic cells and hypersecretion of immunoglobulin M. Studies have shown that recurrent mutations in MYD88 and CXCR4 can be observed at diagnosis in greater than 90% of the cases, having a MYD88, specifically L265P mutation. CXCR4 mutations are frequently co-occur with MYD88 mutations, and these patients tend to have a higher disease burden at diagnosis. TP53 mutations have been found to be associated with inferior progression-free survival and overall survival, and mutated CXCR4 is associated with shorter treatment-free survival and resistance to ibrutinib. Patients with MYD88 and CXCR4 mutations have worse outcomes, and acquired resistance has been associated with BTK mutations. So we included 2 patients diagnosed with LPL or Waldenstrom's within our validation cohort and found the commonly associated MYD88 L265P mutation in both patients. However, the patient being evaluated for the disease relapse had a co-occurring mutation in CXCR4 associated with worse outcomes. Okay, now moving on to mantle cell lymphoma. This lymphoma subtype can have an indolent presentation, though it's rare in about 10% of patients, and is associated with SOX11 negativity and IGHV mutated. More commonly, however, it presents with an aggressive clinical course and is shown to be SOX11 positive and IGHV unmutated. Diagnosis for this entity is based on the detection of rearrangements of T1114 and then rearrangements in CCND1, CCND2, and CCND3, which are not covered by the lymphoma panel. Okay, what is covered by the lymphoma panel are the most commonly mutated genes, that being ATM, which is found in 40% of the patients, mutations in TP53, mutations in epigenetic modifiers. These include NSD2, KMT2D, MEF2B, and SMARCA4. Also mutations in CCND1 and in genes involved in the NF-kappa beta signaling, this being BERK3, COD11, as well as mutations in Notch1 and Notch2. In terms of prognosis within this entity, poor prognosis is associated with mutations in TP53, KMT2A, ATM, and Notch1 and 2 mutations. And treatment resistance has been found to be associated with mutations in the NF-kappa beta pathway, and these include COD11 and BERK3 evaluated on the lymphoma panel. So we included 5 patients within our validation cohort diagnosed with mantle cell lymphoma. For one of the patients, we did not observe any mutations, and we believe this is likely linked to the low tumor percentage and tissue availability for the specimen. For the other 4 patients, mutations were observed in the most commonly associated mutated genes, that being ATM and Notch1, across all 4 patients. And treatment predictive mutations were observed for one of the patients with mutations in TP53 and BERK3. Okay, now moving on to the most common aggressive B-cell lymphoma in adults. That being diffuse large B-cell lymphoma. There are currently 3 molecular subtypes recognized by the WHO classification based on the cell of origin, or the COO, that confer prognostic value for this entity, that being your germinal center, or GCB, your activated B-cell, or ABC, and then your unclassifiable, with ABC associated with poor outcomes. So a few years back, 3 research groups, one from the National Cancer Institute, another group from the UK Hematological Malignancy Research Network, and then a Harvard research group, proposed new genetic subgroups with broad concordance, suggesting that the mutational analysis could be a better alternative to classify DLBCL with prognostic and theranostic values. This is one of the few examples where there were 3 separate studies performed by 3 separate groups in isolation, that then had quite a high level of concordance. It's very rare for you to see that. So everyone was quite excited about these studies and what it could mean for DLBCL in terms of prognostication and therapy. So one of these groups have updated and made available online the LymphGen algorithm for genetic subtyping of DLBCL, which is really convenient. And this online algorithm accepts various forms of raw data and is able to supply a DLBCL subtype, as well as include the confidence probability of it calling that subtype. So what does this all mean? It's great if you theorize this, but do you see this having any sort of difference in practice? Recently, there was basically last year in October, there was a clinical trial called the Guidance 01 umbrella trial that was published utilizing the genetic subtype to guide the treatment. And this trial found that the utilization of targeted agents based on the genetic subtype improved the efficiency of R-CHOP-based treatment in first-line therapy in DLBCL. So now looking at our validation cohort of patients diagnosed with diffuse large B-cell lymphoma, we included 8 patients that were diagnosed with DLBCL in our validation cohort, and were able to subtype all the patients. The most common genetic subtype observed was the EZB-like, but we saw almost all the other subtypes in representation within our validation cohort. This after taking into consideration and identifying mutations linked to the subtyping algorithm, as well as any rearrangements that were observed for the patients. So now just touching on T-cell lymphoproliferative disorders. These are normally ignored because they are less common. So I definitely wanted to be able to include these in today's talk and feedback some information in regards to our validation. So detection of somatic variants can demonstrate clonality and help support a suspected diagnosis. Very unique follicular helper T-cell lymphomas. These include your angioimmunoblastic AITLs, are characterized by very specific mutations that are not common across all of the lymphomas, and that is your DNMT3A and your TET2. These are clonal and can be commonly observed, but the specific mutations are your IDH2, specifically at codon R172, and your ROA, specifically at a specific mutation at G17B. Your IDH2R172 are more specific for have been found to be more specific to your TFH lymphomas. In your T-cell large granular lymphocytic leukemias, your TLGLLs, mutations in STAT3 and STAT5B are the most commonly seen and can support a diagnosis. So looking at our validation data from our cohort, we had 2 patients, each diagnosed with AITL and TLGLL. In both groups, we found the expected mutations. So in our AITL validation cohort, we identified the very specific diagnostic variants, IDH2 at codon R172 and the ROA at codon G17B. These were accompanied, as the literature has already shown, with TET2 and DNMT3A mutations. Then the TLGLL cohort, we also found expected mutations. We didn't see any STAT5 mutations, but we did see STAT3 mutations present in both of the validation patients. Then looking at TLBL, molecular genetic markers are promising candidates for risk stratification within this entity because they represent underlying biological properties of the subgroups. Currently, molecular genetic markers such as Notch1 and FBXW7, otherwise referred to as your NF mutations, also mutations in RAS or PTEN alterations, a flash deletion, your TCR status, and the loss of heterogeneity at chromosome 6q have been identified for risk stratification in pediatric TLBL patients. Your NF mutations predict favorable outcomes within this group, so it's great to be able to identify these, and loss of heterogeneity at 6q and your RAS or PTEN mutations are significantly associated with increased risk of relapse. Your KMT2D mutations, especially when combined with Notch1 and or FBXW7 germline status, are a poor prognostic feature. So we were able to risk stratify our cohort validations participants. We had 6 that were included in our validation, and we identified a number of prognostic mutations that assisted in risk stratifying into either a poor prognosis or increased risk of relapse or favorable outcome. And we had all in representation. So these results basically demonstrated that the panel can also be useful for the diagnosis and prognostication of T-cell lymphoproliferative disorders. So to conclude, Morphology, immunophenotype, and FISH still remain crucial to the workup of lymphoid malignancies. However, patterns of NGS molecular oncoprofiles have been shown that they can support a diagnosis, assist with prognostication, and guide therapeutic decisions. The new Iron AmpliSeq Liverpool lymphoid network panel has performed well and contributed meaningful diagnostic, prognostic, and in some cases, theranostic data for the different lymphoma subtypes, while remaining very much sufficiently simple to allow for a uniform application of this panel. Testing has been available since April this year, late April this year, at Lancet Laboratories, and is ordered by requesting a lymphoma NGS panel. Okay, any questions?
Raquel, thank you so much for a comprehensive talk, and thank you for including the rare T cells at the end as well. So I see there's already a question in the chat box from Dr. Yagelin Naidu, and he asks, do you find MYD88 mutations frequently in marginal zone lymphoma with IgM paraprotein?
We have found MYD88 mutations, but we typically are seeing MYD88 mutations that are not the L265P mutations. They are more commonly seen in other codons. It doesn't mean that you're not going to observe them, but if you do see a MYD88 that is not L265P, those are normally more frequently associated with your marginal zone lymphomas.
Thanks. Anybody else? Is there any questions from the audience? You can either unmute yourself or you can post in the chat box. Moses, I see you have your hand raised. You can go ahead and ask your question.
Thank you so much, Raquel, for the great presentation. My questions, I think I've just 2 or 3 questions. Number one, I was just wondering whether it was going to be useful or useful to include some reactive lymph nodes or those lymph nodes that are reported as reactive in the validation process, just to be negative controls, or to also see the
what comes up.
What comes up, because sometimes one thing that I always I've seen some of these reactive lymph nodes then coming back as a lymphoma at some point. So to see whether we could pick something.
Yes.
So that's my first question.
So because we were doing such a small cohort at the time, we wanted to try and get, or at least see as much information to see how well the panel tied up to what existing information there was. But we do have other very large research groups within the network where they are not so much diagnostic labs, they're just research labs that have done quite extensive testing on existing research cohorts that they have, testing up to about 300 samples. And there, the bulk of the samples that they've included are reactive to see whether they can find anything clonal and at what percentage these are sitting at. So we are in the process of gathering that information, and we actually have quite a lot of specimens that are reactive to compare.
Thank you. And then my the other question is, do you report the variant allele frequency? That's the other one. And also in your diffuse large B-cell lymphoma cohort, did you also include the HIV positive patients in that cohort? Thank you.
Yeah, so we definitely do. We report the variant allele frequency that is observed. We report whether the mutation is known to be pathogenic within the entity, whether it's likely pathogenic, and then we follow the guidelines in terms of grading something as a VUS. So we definitely do include all of the information that you'd normally see in a lymphoma NGS report. It just takes us a little bit more time with this panel because the back end isn't as refined. In terms of the DLBCL cohort, what was your question on that? Again, if you could repeat it.
Were HIV positive patients included in that cohort?
Yeah, so they were not. I think that would be a lovely study for someone to do. But no, we didn't. It was just by chance. The specimens we picked were not from any patients that were HIV positive that we knew of. We tried to pick cases that had already been finished off quite well here at Lancet and had been completed, and there was definitely not going to be a requirement to go back to the material. And yeah, so we were just and we also had a very short time period until we needed to present at SASMO. So it would be great to, I think, do a study on that for sure and see what different types of profiles we're seeing.
Thank you so much, Moses, for your questions. Raquel, then Dr. Jacques Malherbe asks, he hasn't looked at recent guidelines regarding diagnostic workup, but do you think lymphoid NGS is ready for prime time? Myeloid NGS has become part of routine clinical practice, even in the state sector. So do you think lymphoid NGS will follow a similar route? And he also then follows that up by how does the cost compare to the myeloid NGS?
Yeah. So in a way, it's ready for prime time because in the classifications we discussed, there is a lot of reference to evaluating certain genes. And a NGS panel allows you that multiple assessment of all of those genes. And there are already some references to these specific genes. And like we discussed in today's talk, they'll either have some form of prognostication or even better therapy-related relevance. In terms of whether it's where myeloid is, it's not. I think it's more where we were when we started myeloid. When we first started running myeloid at Lancet Laboratories, there was hesitance from the clients to take it up. And we were in the same sort of position we are now, I think, with the lymphoid, where there's bits and pieces of information. There's umbrella trials that are completing, but how many umbrella trials do we have? Not tons of them because the data is only really quite recent. And to be honest, if you look at most of the new clinical trials that are underway now, they've almost skipped over just running normal lymphoma NGS panels and are already looking at circulating tumor and being able to utilize NGS for treatment monitoring. So that's already in the works. The fact that that's in the works means that you've got to have something to compare it to. So I think it's quite imminently going to be ready for prime time. I think the difficulty with the lymphoma is just like with myeloid. We need to get used to the patterns that we see and decide what is something that is useful and what is something that is potentially not as useful. In our network, we've had a few arguments over whether we should be even including some of the most common mutations. Like when I showed you the common mutations that are seen in lymphoma. Do we want to, give so much real estate within the panel to these genes that you see across a whole bunch of different ones, or do you rather just want genes that are helping distinguish? So I think that's all going to come with time, but I think that there are very good publications that have already come out that have already been used in the WHO classification and the ICC classification, which are already moving towards that molecular skew of classifying these entities. And also with the treatments, right? Treatments are all becoming molecularly targeted. So there's a reason for looking for these targets now to see whether patients are going to respond. In terms of cost compared to the myeloid, we are offering this DNA panel cheaper than a myeloid panel. But that is something primarily because we were involved in the validation that took about 1.5 years and did involve quite a bit of cost on our end. But it is a cheaper panel than Myeloid through Lancet.
Thank you, Raquel. And then there's a lot of comments just thanking you for a comprehensive and very elegant talk. Raquel, maybe from my side, just a question, if you don't mind. I think at the end of the day, we are moving to such a personalized medicine and molecular approach, but the clinician can only do with the molecular data. Basically, they can only use it when they know how relevant it is to prognostic, diagnostic, therapeutic targets, etc. So I think what my question would be is, how often do you get a follow-up NGS on these patients, actually evaluating the presence or absence and also the allele or the variant allele frequencies of these mutations that has prognostic impacts? So do you actually receive follow-up marrows or biopsies to monitor these even in private practice?
So we haven't at the moment because we've just launched in April, and we are being quite particular with the specimens that we will recommend for this panel, so that we are able to provide a value add to the patient. So we have to look at what's being asked. We need to understand whether the patient is on a specific therapy that he may be not responding to anymore, and that we can potentially offer some evaluation in terms of the resistance associated with that and motivate for a change in treatment. It really does depend on a case-by-case basis. In terms of the sensitivity, this panel goes down to 2 to 5%. I would say 5% sensitivity on being able to identify these variants. So it is by no means an MRD panel. That would be sort of the next phase of this network that they're looking at and are very keen to convert this panel into. But in doing that, we would obviously have to make the panel also smaller. And I think we're wanting to gather all of that data first to see what are we finding that is really of value, and what are the more common lymphoma types coming through that we would like to include in those sort of analysis. So it's very early days, I would say. I'm just really happy that we've come out with a panel that seems to be cost effective and giving us really good data. Out of the 11 sites within the network, we've got about 4 to 5 that have launched this panel. A lot of the other sites are not service labs. They're involved in research studies, but all of them are involved in quite large cohorts now, utilizing this panel. And that's where it's going to be exciting, I think, is in the next 2 to 3 months when everyone starts aligning all of their data.
I completely agree with you. Thank you so much. Estelle, your hand is up.
Yeah, Raquel, I just wanted to know, you spoke of the phase 1, which I think you did not, I think you called it phase 1,
Yes.
which you did not discuss further, and then you discussed more phase 2. So you took part in both, and the first phase and then the validation phase. How many people would you have? How many people would you have included in both these groups? From, and would your patients come from across South Africa?
Yeah, so phase 1 and phase 2 that I mentioned are not part of this validation cohort. So that was more establishing the panel, putting it through its paces, basically seeing the type of coverage we get with the different specimen types. And we would use very well characterized specimens, most of those not being lymphoma specimens, right? Because there's very little data and were very few panels for lymphoma. So we were using other specimen types that were being run on other very well established comprehensive panels, and basically checking the performance of this design, whether we were getting good coverage over those regions. Phase 2 was then utilizing actual lymphoma specimens to now see how did the panel perform when using specifically lymphoma specimens. And that, again, was well pre-characterized in the sense that they were run on other lymphoma NGS panels. We included 3 different methodologies for the labs that were sending out. And these were now done in duplicate or triplicate to be able to assist with some of the baselining data that we needed for the panel. So we had a number of data points included. I think the initial phase was 64 samples, and then the second phase was 172 data points that we looked at specifically. The specimens that we chose in the first phase more to do with what we had found previously on other panels, and we wanted to include as much diversity, as many different genes as we could, and that was a plan across the network. So each network member would propose specimens, would detail which genes, which locations they had observed, and we'd compile that. The commercial controls were also very important for that because they were quite comprehensive and had a number of genes and sites included. And we would then compare the different genes, the different sites, so that we could come up, for example, with the sensitivity of the panel, and that we had no dropout. So yeah, it was quite robust. At least we followed what the supplier normally does in terms of the validation of their panels. The supplier was just not at the time with the whole CIVD requirements coming into place in the EU. They were focused more on getting the existing panels up to scratch for that, and just didn't have any time to basically invest in starting a lymphoma panel. But they did assist us quite significantly, especially with the bioinformatics backend. We had a few members on our network, but they did support us very well with a couple of experts in terms of the backend.
Okay, well, that's quite comprehensive. So just one thing, you were asked about the HIV samples, but that's for future music. But did you, and I'm sure that's something that you will probably be looking into in future if it is interesting. Would there be differences between different continents, different countries in this consortium or this platform?
Well,
and that's one thing that I wondered if it's something that you said. And I've got one last question.
yes.
This elusive DLBCL waste basket, is there some light at the end of this tunnel? What are you seeing? So those are my 2 questions.
Yeah. So in terms of differences, we definitely saw differences in our data compared to the European data sets that were coming out in regards to, for example, mutations that were coming up that were more common within our cohort. We had to blacklist a couple on the back end that were just not the same as the European cohorts. So they would see completely different false positives basically coming up compared to our cohort. At the same time, we saw a fair number of VUSs that they were not seeing within their cohort. Like I specifically remember STAT3 mutation in one of the upfront specimens that we included in phase 2 of ours that hadn't been seen, hasn't been described in one of our African patients. So I think there are differences, but I would say the bulk of the known drivers are the same. I feel it's like very similar to the myeloid malignancies. It's how the disease is driving. So you're seeing a similar disease driver, irrespective of the cohort. It's just the occasional sample where you'll see something that is unexpected. But for the bulk, for the 99%, we're seeing very similar mutated genes. We compared our data of our 50 specimens, and it compared really well to the published data out there. We weren't seeing any massive anomalies within our cohort. But it would be very interesting to compare the HIV. It is something we will look out for and take note of when we're processing these patients.
Okay, so I did ask about the DLBCL, but perhaps before we get there, now that you've got your operationalized or commercialized panel, what comes first for the pathologist? The NGS or morphology?
Definitely morphology.
Okay.
No
Did
doubt about that.
they come peak and then change their diagnosis or not?
Yeah, it's definitely an add-on. At the beginning, we were asking very nicely to please not send us cases that were difficult to call, because it's just easier for us to do an interpretation within something that is known. But we
Sorry, Raquel, we just lost you there.
Yeah.
We lost your sound. Can you hear us?
Oops. I think we lost her. Oh, there she is. And she's still here.
Raquel, can you hear us? I think she might be having challenges with her audio.
No, there is no audio. I see this. It's like it's disappeared from her. Okay. Well, this was very interesting. Wow. I think we now know what happens in the lab, Moses, isn't it? So.
Indeed, yeah.
Can you hear me?
I don't know if Raquel, I think there's just, there is a problem with her sound right now.
Can you hear me now?
We can hear Raquel. Welcome
Sorry.
back.
I just got cut off.
So
yeah,
very interesting. Sounds like
Yeah, so definitely morphology is still king, and NGS is definitely an add-on. It's an add-on benefit. In some cases, it's been really useful in helping out with the case.
Thank you, Prof. Stels. Then, Raquel, there's a question from Dr. Jacques Miller. But do you have any data on plasmablastic lymphoma?
I think we do. I just may not have presented, but I think we do. I'll email that through if he likes.
Thanks, Raquel. And then it slipped my mind, but I think Prof. Estelle had a follow-up question on DLBCL.
Yes.
Estelle.
Yeah, I just it remains for us who try to characterize our diagnosis better, Raquel. Just simply coming from the routine side, it remains very difficult, that whole area of large B-cell lymphoma. It's a very sometimes, and the pathologists in the meeting will know better than I. Sometimes the morphology helps, sometimes it doesn't. There's certain fish, we at the level of fish, obviously.
Yes.
So the question is, these cases, is it now different? Can you now tell, okay, it's the EZH or the whatever, or the notch 1 or the notch 2? Can you now say those things? And is it now going out like that?
Well, the good thing is that we have the genetic subtyping tool. It's great that LymphGen basically made it an online tool that is very easy for us to upload the raw data. And it's great that it does this calling based on a probability score. So you also can see the confidence that it has in assigning the subtype. When looking at these subtypes, though, you'll see that there's signatures within these subtype groups that have been identified that do cluster with, for example, a follicular lymphoma or a mantle cell lymphoma. So I think it talks to the heterogeneity of the lymphomas, that they share these profiles. But at the end of the day, what's important is that you're getting, irrespective of that, some form of prognostication around these subtypes. And at the end of the day, those are the patterns that we're looking for, and that's what's potentially going to be useful in terms of managing that patient. So I think there is benefit to it. I don't think it's as clear cut as we would want it to be. You know, if you were just looking for one specific mutation that would make it easy to distinguish.
Very interesting.
Thanks, Raquel. Jacques, please go ahead and ask your question.
Thanks, Raquel, for a very interesting talk. Now, just to follow up on my plasmablastic question, I think many of us, I think probably maybe more in state, are often faced with diagnostic challenges with plasmablastic lymphoma versus myeloma, and it's not always so easy to distinguish. I was just wondering if this could, if there is any data in sort of mutational patterns distinguishing those entities, and so basic, where my question comes from. Yeah.
So they do share mutations, unfortunately, but they do share them at different frequencies. So they may be more common in one versus the other. But they would be difficult to distinguish because they share similar signatures.
Okay. Thanks.
Thank you very much. Is there any other questions for Raquel? Please unmute yourself and ask. You're welcome. If there's nothing else, I think we will then conclude the talks for today. Raquel, thank you very much for a very interesting talk, and thank you for this topic. I think it's something that is evolving very quickly, and I think it's something that we all look forward to actually seeing what data the consortium will publish and how it will align to the South African context, contextualized to South African data.
Great. Thanks so much. Thanks everyone for joining, and have a lovely rest of the day.
Thanks. Thank you, everyone. Have a good day. Bye-bye.
Bye.
Bye.